Welcome, Prealgebra students. We are in lesson 79, and we're going to talk about simplifying more difficult notations. So we've already discussed how to do notations like these. We consider that the sign that is in front of the number belongs to that number, and we look at these as independent values and then combine them. But we consider that they're all just being added, which is another word for combined. So we look at this and we say, okay, we have a -4 and a +2. Combine those, that's going to be a +2 remaining. A +2 and a -5, when we combine those, they're different signs. 5 is bigger, so that's going to be a -3 that remains, right? When we have a negative and a negative, the sign remains the same and we add the two numbers together. So -10 would be our final answer. That's pretty straightforward and we can do that pretty readily. But what happens when we are given another operation in between those? If I can get this to work the way I want it to, let me clear the page. All right, what if we have a secondary operation like negative +4 minus a -5 plus 5 minus a -3 plus a -6? Well, we have to simplify this in some way. And the way that we do that is by remembering that this is an imaginary or an invisible -1 in front of all of these. So we sub in that -1 to get the opposite of this number. So the opposite of a +4 is going to be a -4. And the opposite of a -5 is going to be a +5. And then we have a +5 right here. Now the opposite of a -3 is going to be a +3. This is plus a -6. It's just going to be a -6. So now we can treat these the way we're used to. So we have a -4, +5, +5, +3, -6, and we can just combine them the way that we want to. Now, if we look very carefully, we see that a -4 and a -6 combined is going to be a -10, right? +5 and +5 are going to be a +10. So we could actually say -10 and +10 cancel each other out, and the answer is a +3 because that's all that remains. If we took it more slowly, we would say -4 plus 5 is a +1, plus 5 is a +6, plus 3 is a +9, minus 6 is a +3. Same answer, we just went around about it a different way, right? So you can see how sometimes they're going to give us a very complex number and we have to use our little opposite tricks in order to break it down and simplify it. And that's one of the things that they're going to do to us, whether we like it or not. They're going to throw as many negative signs at us as possible, telling us to take the opposite of an opposite of an opposite to try to confuse you. But you have got to stand firm on these rules. If it is even number of negatives, then it equals a positive. If it is an odd number of negatives, then it equals a negative. Okay, remember that from a previous lesson we just had. Even negatives equals a positive, odd negatives equals a negative. And the way you can do that, if you can't remember this rule, is by subbing in that -1, that invisible 1, and multiplying. -1 times -4 is going to give us a +4. Even number of negatives gives us a positive. All right? All right, so let's look at the next problem that they have for us. So we have, here's one right here. Oh, they're giving us a whole bunch of negatives now. All right, here's our problem. So what I want to do first is put the invisible 1 in front of all of these parentheses. Whenever you have a parenthesis or a bracket, just slide that -1 in there, right? Okay, now every operation has a number except for this positive, and you can always slide a 1 in there as well. Every operation needs to have a number. So this is actually 79.2 if you want to write that down in your notebook. The previous one was 79.1. So now we can do the multiplication and get this taken care of. So -1 times -3 is going to be a positive 3. Oh, I don't know what that was. So that's a positive 3. All right. So now we have a -2 and a -1. Well, that's going to be a positive 2, right? -1 and a positive 2 is going to be a -2. Now we have a -1 and a -3. That's going to be a positive 3. Positive 1 times positive 3 is going to be a positive 3. Now we can combine these numbers. We have positive 3 and a positive 3 and a -2. Positive and negative, it's going to be positive because the 3 is bigger. We're going to subtract, so it's going to be positive 1. Right? Those are gone. So now we have positive 1 and positive 3. They're the same sign, so you add them together. Keep the sign, it's positive 4. All right, that is our final answer for 79.2. Let's try another one. Let's just go ahead and do it on the same page. 79.3. I'm going to draw a line here. We have this right here. So what I'd like for you to do is pause the video and see if you can work this problem yourself and come up with the right answer. So go ahead and pause, work this problem, and then press play and see if you get the answer that I get. All right, you should have gotten a -4. So what I did was I slid my -1 or my invisible 1 in here behind the negative sign, and I said -1 times -4. The opposite of -4, that's going to be a positive 4. And then I had a -2, so I brought it down. And then I had -1 times -6 was a positive 6. -1 times positive 6 is -6. Positive 4 minus 2 left positive 2. Positive 2 and -6 left the -4. That should have been your answer. All right, we have one more. Let's clear the page and get some more practice in. So 79.4. We have this right here. All right, so our goal here is to reduce the number of negative signs as much as possible. So I'm going to do that by sliding in my -1, my -1, and my -1. Okay, and I only do that in front of parentheses. You know, you don't do it in between here because it is the opposite of positive 6 already. -1 and positive 4, it's going to be -4. -1 and -5 is a positive 5. Another positive 5. -1 and -3 is going to be a positive 3. And then I have a -6. So now it's a lot easier to combine these numbers. -4, positive 5 is going to be a positive 1. plus 5. That's going to be a positive 6. Bring this down, plus 3. That's going to be a positive 9. Minus 6, because I'm bringing this down, brought this down, and I brought this one down too. This is going to be positive 9 minus 6 is going to equal a positive 3. And that's going to be your final answer. Okay? All right, let's do we have any more of these? Let's see. Nope, that is the last one. So use the mechanism or the notation that works for you. If you need to circle the numbers to isolate them once you get them down to one operator in front of each number, if you need to use that invisible one to help you multiply to get the correct sign in front of each number, do that. If you have any more questions, contact me and I will get to you as soon as possible, and I'll see you in lesson 80.